let's do a couple more examples of generating functions, normal generating functions, before we move on to section 7.3. Okay, example. Suppose you have an unlimited number of nickels, pennies, dimes, and quarters, and half-dollar pieces. So, unlimited number of pennies, nickels, ELS, nickels, dimes, quarters, and half-dollar pieces, and half-dollar pieces. Great. So now we want to figure out the number, determine the generating function, determine the generating function. Gx for the number, number an, which is the name, is equal to number of ways of making n cents with these pieces. IECES. IECES. Pieces. Answer. So let E1 is equal to number of pennies. Pennies. E2 is equal to number of nickels. CK. Blah, 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 blah. Nice. CKL nickels. E3 is equal to number of dimes. E4 is equal to number of quarters. And E5 is equal to number of half-dollar pieces. $half. Then what I want is to solve for n is equal to E1 plus 5, E2 plus 10, E3 plus 25, E4 plus 50, E5. This is what I want to solve, and I'm going to do this by creating new variables. E1 is equal to small e1, capital E2 is equal to 5 times small e2, E3 is equal to 10, E3, E4 is equal to 25, E4, and E5 is equal to 50, E5. And then I am just trying to solve for n is equal to E1 plus, E1 plus E2 plus E3 plus E4 plus E5, where 2 divides E2, 3 divides E3, 4, sorry, what am I doing? Not 3. What am I even doing? My bad. 5 divides E2, 10 divides E3, 25 divides E4, and 50 divides E5. Sorry, that I got distracted. And this is very similar to the case where we had, oh, one of them needed to be even, one of them needed to be odd. If you look at the generating function for this, it is going to be g of x is equal to 1 over 1 minus x for the e1 times 1 over 1 minus x to the 5, because the only things that are going to make e2 are powers of 5, right? So x to the 0, next term is x to the 5, x to the 10, x to the 15, so on, times 1 over 1 minus x to the 10 times 1 over 1 minus x to the 25 times 1 over 1 minus x to the 50. That's my generating function for this. Okay, let's do one last final example before moving on to the next section. Suppose h of n t is the number of permutations is equal to number of permutations I don't need these brackets. Number of permutations of 1 to n which have exactly t inversions. Okay, in case you don't remember what an inversion is, an inversion of a1 dot 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 an permutation a1 to an is a pair of, an inversion is a pair ai aj such that I is smaller than j but ai is greater than aj, right? Basically their places are swapped in a way. The bigger number is in the smaller place and the smaller number is in the bigger place. Okay, we had seen before maximum number of inversions, number of inversions in permutation is equal to, well, for the first place you can have a maximum of n minus 1 inversions. For the second, for 1 you have at most n minus 1 permutations, n minus 1 inversions, n minus 2 for 2, n minus 3 plus dot 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 all the way up to 1 plus 0, and this is equal to n choose 2, right? We have done this before. You can go back through your notes regarding inversion sequences, you'll be able to find this. Okay, so the maximum number of inversions is n choose 2, and therefore h of n comma t is equal to 0 if t is greater than or equal to, not greater than or equal to, strictly greater than n choose 2. Okay, so this is a finite sequence. I am looking at g of x is equal to summation t is equal to 0 to n choose 2 h of n comma t x to the t. That's what I am trying to find. Okay, this is slightly hard because I don't exactly know what h of nt is. How do I find it? Well, let us try to figure out how many permutations are there which have exactly t inversions. How do you get an inversion? Any inversion, number of inversions is basically the sum of elements of the inversion sequence, right? If you remember, the inversion sequence of a1 to an was b1 to bn. The number of inversions was b1 plus b2 plus dot 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 up to bn, right? And so I am looking at, therefore, t is equal to, I am looking at, therefore, h of n comma t is equal to cardinality of b1, the inversion sequence is b1 to bn, where where t is equal to b1 plus b2 plus dot 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 up to bn, right? But what is the special property about these inversion sequences? When I write these b1 to bn like this, where b1 to bn is an inversion sequence, right? And if you recall, if you go back through the notes and see, or as we just talked about up there, b1 is smaller than or equal to n minus 1, right? b2 is smaller than or equal to n minus 2. b3 is smaller than or equal to n minus 3, and so on. So I get that 0 smaller than bi smaller than or equal to n minus I, right? So therefore, eventually, I am going to get that 0 is smaller than or equal to bn is smaller than or equal to 0. And so basically, I am trying to find g of x is equal to summation t is equal to 0 to n choose 2 h of n comma t x to the t. This is going to be the sum of these bi's, which give you exactly t. And from what we have done before multiple times so far, this is equal to 1 minus x to the n over 1 minus x multiplied by 1 minus x to the n minus 1 or 1 minus x times 1 minus x to the n minus 2 over 1 minus x times 1 minus x to the 1 over 1 minus x times, for the last one, it is just 1, right? So it is not 1 minus x to the 0 or 1 minus x. This is the 1, right? 1 minus x to the 1 over 1 minus x is my 1. These are exactly n elements, 1 to n. This is it. And so what I get is pi. This is my generating function is exactly product, let's say I is equal to 1 to n 1 minus x to the I over 1 minus x. Okay? Let me know if you have any questions. This example is slightly hard. You will need to look back at your definition of inversion sequences and why are we getting these things. This is exactly similar logic as before, but if you have any questions, do ask me. I will have office hours regularly as usual. Feel free to ask me. Or, yeah. The book also has this example. You can go through it if that helps you.